Good morning. I am V. Prasannanjaneya Reddy, working as Assistant Professor in the Department of ECE, IARE, Dundigal, Hyderabad. In this session, we are going to discuss about hard real-time scheduling considerations, saving memory and saving the power consumption. For this topic, we need to refer the textbook is Introduction to Embedded System by Shibu KV, second edition, Tata McGraw-Hill edition. Hard real-time embedded system means missing of deadline may cause loss of life or properties. Suppose we are using flight control system. In the flight, if any deviation is not alerted the passengers or pilot within the fraction of seconds, the flight may be deviated and hit the objects, and it may be crashed and people may lose their lives. Similarly, anti-lock braking system. While traveling, we are traveling in the vehicle with a speed of 120 kilometers or 200 kilometers speed something. At that time, if any object comes in front of the vehicle, we are applying the brakes. If you are applying normal brakes means based on the force applying on the brakes, the vehicle will be stopped. Based on the speed we are traveling, based on the force we are applying the brakes. Based on these two parameters, the vehicle movement will be controlled. For normal brakes, if you are applying forcefully, the vehicle may be skid and it will maybe skid the vehicle and accident occurs for normal brakes. Because the vehicle is traveling with 120 kilometers, suddenly we are applying brake means the vehicle may be overlapped and accident occurs. In this case, if you are using anti-lock braking system, ABS means anti-lock braking system. Here, the vehicle movement will be controlled from step by step. Suppose it is traveling with 200 km speed, that will be reduced to 100 kilometers, 100 kilometers to 50 kilometers speed, 50 kilometers to 25 kilometers, 25 to 10 or 10 to 5, 5 to 2, 2 to 0. This will happens within the fraction of seconds. So, suppose I am traveling with 120 kilometers. The vehicle will be controlled step by step within the fraction of second means the accident may be avoided here. Within fraction of seconds. That is, time is very, very important parameter. So we can avoid the accident or we can avoid the collision of vehicle with the objects and save the life. So that is hard real time considerations. So our design, is it meet the deadlines or not? Or any nuclear leakage. Suppose in Japan, Hiroshima, Nagasaki, because of leakage occur in the nuclear plant, the entire area will be affected and that effect will be continuous till here also, 40 years after also. So if they are finding the leakage within the time and controlling means this much of loss not happen. Okay. So here meeting the deadline is very important. That is hard real time. Okay. Like this, we need to consider different type of scheduling algorithms. Which scheduling algorithm meeting the deadlines? That needs to be choose and use in our design. Either shortest job first scheduling, preemptive, shortest job first scheduling algorithm, or preemptive priority based scheduling algorithm based on the requirement. Be clear. Next, saving memory space. How we can save the memory? So, if you are expert in that language or in the tools, with the minimal code, we can provide the same functionality without changing the functionality. Suppose I want to add two numbers, 1 plus 2 equal to 3. For this requirement, in the normal programming, I am taking one variable a equal to 1, b equal to 2, c equal to a plus b. If you are writing like this, I need to initialize 3 variables as integers. Integer occupies a short integer or integer, long integer. Suppose I am taking unsigned integer, it takes 2 bytes space, and 3 variables taking 3 into 2 bytes. So totally 6 bytes memory space will be occupying here. The same functional will be designed using a equal to a plus b. Suppose I am using this line instead of c equal to a plus b. So in this type of code, I am using only 2 variables. 2 variables means each variable is unsigned integer and it takes 2 bytes. So here I am taking 2 unsigned integers. So totally 2 into 2. 4 bytes of memory space. So just compare. For adding 2 numbers, if you are writing like c equal to a plus b, takes 6 bytes of memory space. The same functionality will be designed by using a equal to a plus b. It takes 4 bytes only. 2 bytes memory space will be reducing here. In the same manner, if you are understanding the functionality very clear, and if you know the very well in that language or tools, development tools and languages, we can reduce the number of instructions required for providing that functionality without changing it. So, substitute or eliminate large functions. Watch for repeated calls to large functions. For repeated operations, we can write only once, call that function. Instead of writing the same instructions number of times or repeatedly. Second, make sure that 2 functions do not use same thing or does same operation. So why we need to write the same functionality repeatedly? No need to write. So don't write like that. Or don't use same functions. Because the same functionality will be already designed. Next, check that our development tools are not taking much time for development. Okay. So how much it is taking for designing our programs. Next, configure our RTOS to contain only those functions that are needed. So write the requirements, only desired requirements only. Don't write other things. Sometimes some of the purposes we are writing intermediate programs. If it is not required, eliminate that one to save the memory. Save memory. Next, we should always look at the assembly language listing created by our class compilers to see if certain of our C statements translate into huge number of instructions. Suppose if you are writing the C language, if you design the applications using C language, while converting into machine level, how many number of instructions will be generated from this basic program? If you are writing same functionality in assembly language, how many number of instructions are there? Check it once. Which one contains more number of instructions? Eliminate that one. Because the same functionality will be providing with minimal number of instructions. Next, use static variable instead of relying on stack variables. Okay. Static means stationary, no change. Variable means that value may be varied. So we can use a maximum static variable instead of variable. Why? Because to avoid more space. Next, for an 8-bit processor, use char instead of int variable. So 8-bit means it will perform all times. The register size is 8-bit. So you can do the 8-bit operations. If you are using integer variable means it takes 2 times the same operation. It requires 2 clock cycles. If you are defining as integer. If you are defining as character, the size is 8-bit only. So we are occupying only 1 byte size instead of 2 bytes. So half of the memory space will be reducing here by initializing the variables as char. Like that you can check what is the processor size, either 8-bit or 16-bit or 32-bit or 64-bit. Based on that or based on the operation. If it is 8-bit operation, we can define as 8-bit information variables. If you are defining as 16-bit variables means the required size is more, double the size. So avoid that one. Then we can save a lot of space by writing our code in assembly language. Because assembly, if you writing the high level language, sometimes while converting from high level to machine level, that generates more number of instructions. So compare that one. Which one is having less instructions? We can use that less number of instructions without changing functionality. Okay. Like that, we can save the memory space required for our design. Next, save power. How we can save the power consumption in our design? The basic point is disable the unused peripherals. Automatically, whatever the power consumed by that undesired peripherals, that much of power will be saving here. Let us consider one example. Suppose while doing the operations, running mode means while doing the operations. At that time, the current consumption is 32 milliamperes. Okay. So at that time we are using system clock. We are using CPU. Core means here processing element or CPU. And we are executing the instructions. At that time, the power consumption is or current. The current consumption is 32 milliamperes. While in sleep mode means we are not using the clock signal. So we can disable the clock here. So whatever the power consumed by the clock, we are saving here. In the same time, we are not executing the instructions. Whatever the power required to execute that instructions, that power also saving here. So finally, in the sleep mode, the same device consumes 10 milliamperes. So how much power is currently saving here? 22 milliamperes. Again, coming to the deep sleep mode, we can disable the clock. Similarly, we can disable the code. We can disable remaining slow peripherals or low speed or medium speed peripherals. At that time, it consumes only 1 milliamperes. We are not mentioning the memory devices or I/O devices or additional hardware circuits and communication peripherals. In that, medium speed, low speed peripherals are there. In the beginning time, we are enabling all peripherals. In the sleep mode, we are disabling the CPU. Again, deep sleep mode, we can disable the additional hardware also. So, since we are disabling additional hardware and some I/O peripherals and memory peripherals, it consumes only 1 milliamperes. So, if you comparing with sleep mode, it reduces 9 milliamperes. While comparing with running mode, it saves 31 milliamperes. Okay. Coming to the hibernation mode. In this mode, We can switch off the CPU power, clock power. We are stopping the execution of core components. So it consumes only 5 microamperes. Just compare. Where is 532 milliamperes? Where is 5 microamperes? Lot of power will be saving. Again, coming to the hibernation mode in real-time clock mode. Real-time clock mode means we can disable VDD here. Here VDD is on, here VDD is off condition. Since VDD is off condition, whatever the voltage or power is consumed in this VDD, that's also saving here. So it consumes only 1.7 microamperes. Again, without real-time clock, in the hibernation mode, no real-time clock. In that time, it consumes only 1.6 microamperes. Why means? We are disabling VDD, we are disabling the system clock, we are disabling the CPU, we are disabling the clock, here disabling the execution of instructions. So if the device is not operating, or we are not using the device, either mobile phone, either whatever the embedded system we are designing here, at that time, if we disable all these things, we can save so much power, that is 32 milliamperes to 1.6 microamperes. Just compare how much power is reducing. Okay. So finally, by disabling the unused components, we can save the power, whatever the power consumed by that device. Like that, we can save. We can design the scheduling algorithms for disabling unused peripherals. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.